Hello everyone, I'm Sartre. I work in the Medical Informatics Lab at UCL Louvain in Belgium. I'm going to present to you the radiology model developed by us that helps connecting GNUHealth to the Autank DCOM server. I would like to show you how the IT infrastructure of a hospital with a radiology department could look like. It contains multiple components or subsystems. The first system is a hospital information system, such as GNUHealth, the laboratory information system, and the radiology department. They are integrated via, for example, misconnect connector, the health information exchange, which is responsible for sharing information data with remote system or another department. Now, we want to look what happens inside the radiology department. One important system is the radiology information system, the report repository, which stores the diagnostic results, such as from voice recorders, doctor findings, and critical results, and the PARC system, such as the Autank PARC system, a picture archiving and communication system, is electronic management of the storage, retrieval, distribution, and presentation of medical images. The modality device, such as CT, they are all connected via the misconnect connector. The data exchange between them can use higher 7 messages. The IHG radiology RAID is a framework developed by integrating the healthcare enterprise to ensure secure interoperability and communication between radiology systems such as image equipment, PARCs, and electronic health records. The general workflow starts with the registration. The patient is seen by the physician and a new order is created. The radiology information system RIS system processes the order, retrieve the relevant studies, generate a work list, and share it to the modality device. Once the images are correct, the images are stored, and then expert can validate the image quality, record the diagnostic findings, and release the report to the report repository. Finally, the completed report is returned to the physician workstation. This slide explains the goal of the integration GNUHealth with the Autank PARC server to create a connection. The Autank server can be either local or remote. The goal of the integration project is to enable GNUHealth users to browse, view, and manage the image studies stored in the Autank PARC server. We want that this integration feels natural for the GNUHealth users. This means they do not have to leave the GNUHealth client for basic tasks and ensure that the radiology modules aligns with GNUHealth architecture and maintain its security and access control. The IHG radiology RAID standard outlined in Volume 1 for integration profiles and Volume 2 for translations. The profile ID profile explained how to retrieve image data from PARC and display it in DCOM viewer. The IEO profile image enabler office focus on the integration of remote electronic health record systems. The patient information reconciliation ensure accurate recovery and the integration of patient information, such as in an emergency room scenarios. Based on the requirements or challenges, the desired features for the integration of mapping patient in GNUHealth and in OTANC server. The mapping means that we have to find the relation between patient in GNUHealth patient list and the patient names used by the image data on the PAC server. Uploading image data to OTANC using GNUHealth client, synchronizing metadata between GNUHealth and OTANC, preview image data in GNUHealth, visualization of patient image studies using GNUHealth OTANC DCOM viewer. Before I show you how our new model works, I want to quickly explain what OTANC is. The OTANC is a PAC system. It's integrated in GNUHealth. It is a lightweight DCOM server for medical imaging used in clinic, industry, and research institutions. The key feature is simpler integration with REST API. We provide many plugins, such as worklist, server DCOM viewers, and Java plugins. This year, we developed the new fire imaging study. It reports the detail of the entire DCOM study and associated information. The OTANC Explorer tool should be used in the future work. The image data can be uploaded via this Explorer to reduce the workload of GNUHealth. Here are the different DCOM views available with OTANC PAC: the StoneWeb view, the integrated OHIF viewer, and the KitWell view. These views can be easily accessed and linked through the OTANC Explorer tool. There are already a model for connecting GNUHealth to OTANC. The old version used the Baron library, which provided advanced image processing functions such as segmentation and 3D visualization. However, it was limited to DCOM server interaction and managing large image sets over a network. It is supported, but the old model supported the periodic synchronization image data. For the new version of the implementation, I decided to use PyOTANC, a Python wrapper for the OTANC server, to focus on the DCOM file management, storage, retrieve, handling, and display of the image data. This is the new architecture of the radiology model that I created. It has two main functionalities: data management and OTANC server configuration. The development follows the structure guided by GNUHealth system. Before the GNUHealth server can connect to OTANC server, the user has to configure the connection parameters. For this, we have a new view. The user can configure the local and the remote OTANC server here. The new OTANC configuration has a new URL validation function to check if the URL is a real OTANC server link. This is a validation here, validation of the URL link to the local and remote OTANC server. Before the user can access the image data on the OTANC server, the user has to tell GNUHealth to which patient an image study belongs. It is very important to know that DCOM image data is immutable. The user is not allowed to modify the metadata in OTONC. It can only be mapped. The new model allows users to manually link patient data with image data, select a study, and select Find the Patient button to open the patient list page, and then select patient. Once linked, the patient's image data can be displayed in OTONC view, and each image instant can be previewed. A semi-automatic mapping feature is planned to reduce the workload for the doctor. When the mapping is done, the user can now access the image data. This is the image data management. The users can upload image data to the configured OTONC server, delete image data from the server, and synchronization of metadata between OTONC or GNUHealth and OTONC PARC system. To view images, simply select the relevant study and click on the button in the table to open the DCOM viewer. This is a Stone Web viewer. This is integrated OHIF viewer. The user can select an instant from the series in the patient study to preview it in a PNG format. Here, this is select. You can see there are a lot of instances in one series. Select one instance. You can open an image. As instant in PNG format. It is important here. The expert can check the quality of the image and to check whether there buried information in the image. A patient study often includes many series, each with hundreds of images. To upload this image to OTONC server, I have introduced a new GNUHealth widget. The widget lets users select multiple DCOM files from their computer and to upload them direct to OTONC server, making this process much easier. This is the state of the new implementation of the radiology model, but I plan the future work to add support for the new file resource imaging study in the GNUHealth file server to simplify the integration because they both can share the same protocol using the OTONC Explorer 2 user interface. Add a semi-automatic patient mapping to reduce physicians' workload. The OTONC Worklist plugin can be used within GNUHealth. I can add an image segmentation feature to GNUHealth. This is my presentation. Thank you for your attention. Any questions or discussions? Thank you very much.